Hi everybody. So continuing our discussion on scatter plots and trend lines, this time we will be working with lines of best fit. So what is a line of best fit? So the line of best fit is actually a trend line that shows the relationship between two sets of data most accurately. So when you are being asked, find equation of a trend line, you can have multiple possible ways on how you can write that. But if it is the line of best fit that is being asked of you, this is where you will make use of a graphing calculator so that you can get the exact trend line that will represent your data sets. Okay. Now, one thing that you will notice when you use the graphing calculator is that there will be a coefficient that is represented by the variable r. So that's what we call as the correlation coefficient. That coefficient could be a number, and that number is anything between -1 to +1. So it's going to be a decimal, and you have a very small range there from -1 to +1. And that coefficient tells us how closely the equation models the data. Okay, so it means that if you have a negative value, a -1, if your correlation coefficient is nearer to -1, it means that your points are very close to each other and that you have a negative correlation. All right, if your R is nearer to 0, it means your data is all scattered, and so there is no correlation in there. And then the closer it is to +1, so of course it will have a positive correlation, and the more tight the data points are to each other. Okay, so again, when we're talking about line of best fit and correlation coefficient, a graphing calculator will be important, and of course we will be using Desmos for that. Okay, so let's have this example. So we need to use a graphing calculator. We are looking for the correlation coefficient up to 3 decimal places. This is our data set, and we need to predict the cost of attending in 2012-2013 academic year. Okay. All right. So this is our graphing calculator. That's Desmos. And I have here a copy of our data set. So what we need is to create a table. So for you to be able to do that, make sure that you are on the graphing version of Desmos. Click on Add Item and then Table. Okay, so when you type in your X values, so if you would go over here, our X values would be the academic school year. So we will just use the first year that was mentioned. Okay, so this is 2000, 2001, 2, 3, 4, 5, and 6. All right, and then you will have to enter your Y values, this corresponding Y values here. And so that would be 3508, 3766, 4098, 4645, 5126. I have a second screen, that's why I'm able to get them in. Okay, 5492, and then 5836. All right, so this is your data set. We need the correlation coefficient for us to be able to do that. And this is something that you have to remember. Okay, make sure you write this down on your notes. So for us to be able to get our our correlation coefficient, what we will have to type will be a formula. It's going to look like the slope-intercept form, but there will be some tweaks on it. Okay, so on your Desmos, you have to do Y sub 1. Okay, just click on 1, it automatically becomes a subscript. You click on that curly sign like that. Okay, and then you have mx1, okay, plus b. Okay, so you will notice that, so this is y equals mx plus b. Now remember, when you're plugging in this formula, it has to be a curly dash like that, not the equal sign. And you have to make sure that you have the sub numbers, y sub 1, x sub 1, y, because we are getting it from this table. Okay, so this equation is going to come from this data set here. Now, what do you see is the R? Our R is 0.996. And by the way, if you want to see the points being graphed here, because you are in 2000 something, so it's gonna be somewhere over there. There we go. Okay, so those are our points in there. And so what we have here, so you will see that our R is 0.996. So where is it nearer, to -1 or to +1? So this is very near +1, all right? And so what you will notice is that you will see that this will be a positive correlation, okay? A strong positive correlation. So you will see here, I made some adjustment on how the plot would look like. I simply changed the x-axis to be somewhere from 2000. The x-axis will simply show us 2000 until 2010, let's say, okay? So you can change that so that you can see that it is a, how do you call that? It is really a positive correlation. Now, what is the equation of this line of best fit? So if you will see here, you have an M. So 409 point, let's say 43, okay? So your equation here will be, can I write it? Oops, sorry, no. So your equation, remember, your equation should be y is equal to mx plus b, correct? Now, as you will see here, our m is given as 409.43. So you can have it 409.43. Okay, and then the B is at negative 815,447. Okay, so that's a very, so it will be minus 815,447. And you will see, okay, let me just change the color of this one here. So I can have it as red. Okay, so if I deactivate that, that's the line. Okay, that is the line of best fit. If I deactivate that and I activate the equation based on these parameters here, that's the value of your m, that's your slope, and that is your y-intercept. So the equation of the line of best fit will be y is equal to 409.43x minus 815,447. So that is how you can use your graphing calculator to create an equation. So now the question is, what will be, so if you will go back to the, if you take a look at your notes, you will see the question there is, what is the cost of attending in the year 2012, all right? So what we can do is simply, we replace the x. Our x, if you would remember, is the year of the school year. So if you change it to 2012, okay, we can say that the tuition will be around 8,326 and 16 cents. Okay, so that's your prediction based on the equation that you are able to get from the line of best fit. Okay. Okay, so this is our equation based from our graphing calculator. Okay, so it is very important that you type in your data very carefully. Make sure that you do not mess up those numbers so that you can get the correct line of best fit equation. Okay, so the last part would be on causation. So identifying whether relationships are causal, meaning if this happened, will it really be happening with this one? Okay, will this be an actual cause about this particular scenario? So causation is when a change in one quantity causes a change in the second quantity. Okay, so I have here some situations. Is there likely to be a correlation, and if so, does the correlation reflect a causal relationship? So will the first quantity affect the second quantity? So for example, the number of loaves of bread baked and the amount of flour that's used. Well, definitely the amount of loaves will be depending on the amount of flour used. The lesser flour you use, the lesser amount of bread that you can, correct? So there is definitely a correlation between the number of loaves of bread and the amount of flour. And will it be causing will one quantity cause the result of the second quantity? Definitely. The amount of flour will have an effect on the amount or the number of loaves of bread that could be baked. All right. The other situation, let's see here, is the number of mailboxes and the number of firefighters in a city. All right. So is there a correlation between the number of mailboxes and the number of firefighters? Well, you know that if you have a certain number of the more mailboxes you have, it simply says that the higher population the city will have. And if that is the case, then you will have more firefighters as well. All right? The bigger the city, then the more firefighters there will be. But if you increase the number of mailboxes, does that mean that the number of firefighters will also increase immediately? Definitely not, okay? If you install, like, let's say in one house or in one place, you have like several mailboxes in there, it will not, like, for example, in apartment complexes, there are multiple mailboxes in there. But does that increase the population of your city? No. The population of the city will determine the number of the firefighters, not the mailboxes. And so, for our second situation, there is no causal relationship. Okay? So, to summarize our discussion, you can determine whether two sets are related by graphing them as ordered pairs. That's our scatter plot. And if two sets are related, then you may be able to use a line to estimate or predict values from it. Okay.